let's look at the chi-square test for independence. This test involves one population and two categorical variables. And what we're interested in here is whether these two variables are independent or they're related. So our null hypothesis is going to be that they're independent, and the alternative hypothesis is that they're not independent. In other words, they're dependent, or there's an association or a relationship there. Okay, this won't get us cause and effect, but it will say that there's, maybe something going on with these two variables. So the idea behind a chi-square test for independence is related to something we learned in the probability section for this class. So there's a corollary to one of our rules that says if the probability of A, given that event B happens, is equal to the probability of event A, then we know that these two events are independent. Okay, but what happens if the probability of A given B is close to the probability of A, but not exactly equal? What a chi-square test for independence allows us to do is it will help us to quantify, is it close enough that it's likely that it's independent, or is it too far away that really we can rule out that these are independent and we have some sort of relationship going on there? Okay, the way that we organize this particular data is in a two-way table. So let's take a look at an example of that. So this particular example is marital status and drinking. So the marital status has 4 categories to it. So it's over on the side. And then the alcohol consumption is along the top. So that's our other categorical variable, and it has 3 categories. Okay. So this looks a lot, and in fact is like the contingency tables that we looked at earlier in this class. So this is what that two-way table is going to look like. And our process here is going to be very similar to what we were doing with the chi-squared goodness of fit test. So again, my null hypothesis is that these two variables are independent. The alternative is that they are not independent, that there's some sort of relationship there or association. Now, our assumptions look the same, but there's one little twist to these. So let's review these quick. These are very similar to the ones for goodness of fit. So we need some sort of random sample. And then when we calculate our expected values, we need all of them to be greater than 1. And at most, 20% of them are less than 5. Or another way of stating that is at least 80% are 5+. Okay. So here's the twist. We're going to change how we calculate the expected value for this. So the expected value E is equal to RC divided by N. And R is actually the row total, and C is the column total. And then N, as always, is our sample size. So if we go back and look at this marital status question, if I start in this first box here, so this is single people who don't drink at all, my row total is this 354. Put that down. And I'll multiply that by my column total, which is 590. And then I'll divide that by the 1170, or I'm sorry, that's a typo. That should actually be 1772. So let me fix that there. Okay, and that will give me my expected value. And then I can do that for all of the boxes on here. Okay, once I've done that, I want to check and make sure that they're all greater than 1. And at most, 20% of them are less than 5. So if I've met all that criteria and I have these 2 categorical variables, the process I'm using is a chi-squared test for independence. Now the way I calculate my test statistic is the same as it was for the chi-squared goodness of fit test, meaning that I'm going to take for each box on that table the observed value minus the expected and square that, and then divide by the expected. My p-value process is going to be about the same. I can use that chi-squared distribution. We can always use that to get a probability. Or I can use the chi-squared.test command. Okay, that's also an option for getting a p-value. If p is less than alpha, we'll reject our null hypothesis, meaning that these two variables are related or associated, or they're dependent. If p is greater than or equal to alpha, we do not reject our null, meaning that we do not have evidence that they're not independent. Okay, so it means we have a suspicion that they are in fact independent. Our conclusion statement is with a p-value of blank at the blank percent significance level, we do or do not have sufficient evidence to conclude, and we'll put our two categorical variables here, are associated. All right, so that's going to be our process for the chi-square test for independence.